We're at gotomath.com. I had to take a drink there. Sorry about that. Let's do hyperbolic. We're working down that list. And what are we doing? I think this one here, 5.2. Whoa, what is all that? This is a trick here, it looks like. Well, let's write all that down. It's going to be a trick. No, no tricks here. But this is one, if I remember right, that you could give to a survey to calculus class, CSCH, and that's never even seen a trig function, and they should be able to work this out if they understand the concept. Yes, that would be a good problem. Alright, so let's hit dx. Okay, this way you know they know the concept. I think that's what this is. I'm trying to remember. Alright, I'll find out here in just a second. Write this down. It'll all come back to me. It's been a while since I programmed this one in. Alright, so we got the integral of 4 something. Okay, cosecant hyperbolic x times cotangent hyperbolic cotangents, which I think where you're supposed to really say that. And then we have cosecant h squared of x dx. Which actually can be rewritten. Since, look here, I've got another one over here, and when you multiply by this, you'd end up having to the third power, right? So you could actually combine this to the third power to even mix to the confusion. No, actually, you do have to know the derivatives, now that I think about it. I guess I was thinking of something else. Yeah, I believe I was. Okay. This particular one here is we're going to have to use looks like U substitution. Alright, we're going to be using U substitution. Yeah, cosecant. Okay, cosecant, cotangent. Yeah. Alright, we're going to let U equal the CSCH of x. Okay. And du is equal to, so you got to remember what's the derivative of this guy here, and that derivative is actually negative cosecant, hyperbolic cosecant of x times and then dx right here. All right. So you notice we have a negative. We've got one. Let's see. We got hyperbolic. I hate to say this every time. Hyperbolic cosecant, hyperbolic cotangent here. So we have both of those. We have the dx, and we even have a negative out here. How convenient. So that means that this, and this can all get replaced, right? And what can this be? Well, that's going to end up being, so let's just rewrite this. Now we have this 4, but that's okay. We can just bring it out here and get it out of the way. That doesn't have to be replaced. You can just get it out of the way. Alright, so this is going to end up being U squared du. So you see this gets replaced, except there's a square up here. Alright, and now we can go ahead and take the integral of this. So you should easily be able to take the integral of this right here. So there was something I said earlier, and that was that a survey calculus student could do this without knowing trig functions, but that was false, because you need to know how to take the derivative of this, unless the teacher puts this up there as a hint or something at the top of the page for that problem. Yeah, I guess you could do that. All right, I'm sure there's people out there going, please don't give my teacher any 3 plus C, any ideas. All right, so let's see. There are some problems though that I think we don't have to do that. Yeah. Never mind, forget it. 4u cubed over 3 plus C. I think we're done, aren't we? So now what we got to do is get everything back in terms of x. Let's just pull this 4/3 out front. So our u happens to be CSCH of x raised to the third power, and then plus the big old constant. Don't ever forget that, or it will be wrong, I promise. Okay, so that wasn't too bad, right? 4/3 cosecant h cubed, da da da. Yeah, that's it. That looks like that's it. All right, that's it. Let's go back to the house. Check out the house. Or go to math.com. Come on by, check it out. See you later.